Okay, so curl and divergence. So this is the formula for curl. The context is where you have a vector P, Q, R. And so P is a function. So each one of these is a function of X, Y, and Z, or potentially a function of X, Y, and Z. So P is a function of X, Y, and Z. Q is a function of X, Y, and Z, and R is a function of X, Y, and Z. And so the curl is another vector field where it's the partial of R with respect to Y minus the partial of Q with respect to Z, and so on. That's the I component. This is the J component. This is the K component. And then the divergence is the partial of P with respect to X plus the partial of P with respect to Y plus the partial of R with respect to Z. So the divergence is in the scalar field. So it's just a one dimension thing. So it's a function in one variable, or there are three variables, but X, Y, and Z. But so what I mean is this: the curl of F, that goes from R3 to R3. Okay, so its range, or I say codomain, or range, is in R3. The divergence is a function from R3 to R. Okay, so they're different. So this is not a vector right here. This is just a function in X, Y, and Z. Okay, this is a vector here, so it's three-dimensional. Okay, so anyways, here we have some more things that go on. One thing that I should mention is that if F is conservative, then the curl is 0. Okay, and then it goes back the other way for every single case that you're gonna see. But there's like weird cases where it doesn't, where you could have the curl being 0 but not being conservative. But for all practical purposes, let's not worry about that. If the curl of F is 0, then you're going to be conservative for everything that you see in this class. Okay, so number 1, find the curl and divergence of this vector field. So let's go ahead and work this problem. So this is our P, and this is our Q, and that's our R. Okay, so the curl of F, we'll write it in vector form. So the first one is the partial of R with respect to Y minus the partial of Q with respect to Z. And then the second one is the partial of P with respect to Z minus the partial of R with respect to X. And then the third one is partial of Q with respect to X minus the partial of P with respect to Y. Okay, so partial of R with respect to Y, what is that?
2y x squared.
Yes, 2yx, and there's a Z there too. Don't forget that.
Oh, see. Okay.
Okay, then we have partial of Q with respect to Z.
2c x squared y.
Okay, those are the same, right? Wow. I can't wait, so I'm just going to say that's 0. Okay, the next one, dp dz.
X y squared, and there's a 2 as well. C.
Yeah, and then the rdx right here.
X 2x squared y squared c 2x. Oh, sorry, 2x.
Yeah, the y came down. Okay, that's also going to be 0. Okay, wow. And then this last dq to, what is it, dq to x, sorry.
dx, 2x y z squared minus 3y 2y squared 2y x z squared.
Well, that's also 0. Okay, so the curl is 0. What does that mean?
It's at the origin.
Yeah, it means that this is a conservative vector field.
Oh, conservative.
So that means that f is the gradient of some potential function. Okay. It looks like it looks like that, just the top off the top of my head. It looks like 1/2 x squared y squared z squared. So if you take this function right here and take the partial with respect to x, you're going to get this. Partial with respect to y gives you this. Partial with respect to z gives you that. Okay, so that's the potential function. That's not part of the problem. But anyways, the curl is 0, 0, 0. So if you put it in vector form like that, you should get the right answer. And then for the second part, let's look at the divergence div f, and that's this one here. Okay, so that's the partial of p with respect to x plus the partial of q with respect to y plus the partial of r with respect to z. Okay, so partial of p with respect to x, what is that going to be? So we're back here again.
Y squared z squared c squared.
Yep, great. Oh, squared there. Okay, and then partial of q with respect to y?
X squared c squared.
Yes. And then partial of r with respect to z?
X squared y squared.
Good. Okay, so that should be the divergence right there. Okay, so like I said, the curl is going to be a vector valued function. This still can be considered as a function of x, y, and z, but it's always going to be 0, 0, 0. And then the divergence is just one function in x, y, and z, not a vector field. Okay, so let's take a look at this exercise number 2. And we're going to try to figure out the correct answers. So here you have a vector field that's being drawn here with a bunch of vectors. And what can you tell about these vectors? What do you know about these vectors? What do you notice? They're all pointing upwards, right?
To the positive side. Yeah, upward.
They're pointing upwards. Okay, so they all point upwards. They point in the positive. They point in the positive y direction, right? Okay, so they're pointing in the positive y direction. And what happens as you go up?
Bigger and bigger.
Yeah, they're getting smaller. Okay, so they're getting smaller as you move in the y direction. I should say positive y direction. So they're all pointing in the positive y direction, and they're getting smaller as you move in the y direction. Okay, so now your vector, remember, is p, q, r. Okay, so they're pointing in the positive y direction. That means that the p and the r are 0. Okay, so that means that the p and the r are both 0. So that means, and then also means the q is the only one that's happening. Now, as you move up, as you move in the y direction, these are getting smaller. That means that dq, dy is negative. Okay, they're getting smaller, and they're only pointing in the q direction. So p and r are both 0. They're gone. Okay, so that means that if you're looking at the okay, so first it's the divergence. So this is gone and that's gone because the p and r are both gone to begin with. And if dq dy is negative, what is the divergence going to be?
Negative.
Yes, negative. Okay, see if, and then try that answer. See if Webassign likes that.
It worked.
Okay. Yes. Yeah. Great. Okay. So now, because p and r are 0, that means that that one, and that one are gone, right? And also, it's only dq dy that really matters. So they're not. It's not as you go to the right, they're staying the constant. And also, it says something up here about f is independent of z and a z component. So that means that that's gone. And the z component is 0. So as you're going to the left or the right, as you're going in the x direction, they're remaining constant. So that means that this is 0. So all those are 0. Okay, so then it asks, in what direction does this curl point? And then it doesn't point in any direction, so none of them. Okay. Okay, great. So let's take a look at the next one. So what direction are these pointing?
To the left and to the right.
Okay, so pointing in it's the x direction, so left and right is x, right? And so that means that q and r are both 0. And also says that z component is 0 anyway. So q and r are 0. So we can whack out all the q's and the r's. So I'll go ahead and do that. Okay, so those are all 0. Okay, now, as you go left or right, these are constant, right? As you go from left to right. So consider these 3 things right here. Okay, so first of all, f is independent of z. That means that's 0. F is independent of z. That means that's 0. Okay, so we can knock that one out too. Okay, now look at this. Okay, so dp dx. As we move in the x direction, do these arrows get smaller or larger? As if you're like along this line here, are they getting smaller or larger along this when you move this way?
No, they're constant.
No, they're constant. So that means that this is 0. Okay, so they're constant as you move from right to left. So that's 0. So that's gone. Okay, so that means the divergence is already 0. Okay, now, as you go up and down, or let's say as you go up, what happens? As you go up, what happens?
It's still constant. It goes constant up the direction.
Okay, no, this arrow and this arrow is smaller than that arrow. And then this arrow is pointing the other way. And then this is even pointing the way more. So are these getting larger or are they getting smaller? well, they're getting smaller here, but these are pointing in the negative direction, right? And this is less negative, and now this is positive, more positive, more positive. So this would this going to be greater than 0 or less than 0? dp dy. Greater than 0, right? Because here they're negative. This is less negative. That means that the derivative is, that means that the partial is positive. That means it's increasing. Okay, that means that these are increasing in the, that means that P is increasing as you're going up. Okay, because here it's negative, here it's less negative, even less, and then now it's positive. And then more positive and even more positive. Okay, so it's dp dy is positive. So you only have this one to deal with. So if dp dy is positive, then the curl, now the curl is negative dp dy times k. So that means what? This is a k direction, right? Which is the z direction. Okay, so it's going to be positive z or negative z? Well, if this is, here's a negative sign here, and this is positive, right? So that means this whole is going to be negative. Okay. So it's going to go in the negative z direction. Okay. So that's just a little bit to try to help you see, I don't know, try to help you see a little bit of how these things interact. Okay, so number 4, determine whether or not the vector field is conservative. If it is, find a function f such that the f is the gradient of f. Okay, so they want you to do these calculations. You don't necessarily have to. You can go try to find this from the beginning, and then if you're really good at finding these, and you can tell when you can't find one. But they want us to calculate the curl, so we'll go ahead and do that. So here's our P, and here's our Q, and here's our R. Okay, so the curl is this one here. So we'll just look at this instead of rewriting everything. So I've got it written right there. Okay, so the first thing is dr dy, and what's that going to be?
3x squared c squared.
Great. And then you're going to subtract dq dz. Which
2c to the power q.
Yeah. Okay, so that's 0, right? So that's good. And then, or maybe that's bad because, like, if that wasn't 0, then we would be like, yay, it doesn't. We can say right off that, oh, it's not conservative. Oh, throw it out. Okay, so the next one is dp dz. What's dp dz?
3c squared xy.
Yes, xyz squared. Okay, and then dr dx.
dx 6x y c squared. No, it's not 0.
Okay, that's not 0. Okay, so that means
Does not exist.
Not conservative. Go home. Go home. The baseball game got rained out. Okay, so D and E. Okay, so number 5. So here are the curl let's see here, dr dy, so that would be this one. So this is, okay, p is just 1. Okay, so dr dy would be cosine z. Yeah. And then minus dq dz.
See, it's gonna be cosine.
Yeah, that's also cosine z. Okay, then the next one is dp dz. Now this is just going to be 0. And then dr dx. There's no x's here, so that's also 0.
Hmm.
Okay, then the last one, dq dx.
dq dx 0. There's no.
Oh yeah, that's right. There's no x's in here. And then dp dy is also 0. Okay, so that's going to be 0.
Ah.
Okay, so that means there is a potential function. And we know that the partial of f with respect to x is 1. The partial of f with respect to y is sine z. I'm just reading off of here. And then the partial of f with respect to z is y cosine t. Okay, so it's a function of x, y, and z. Here, we know that the partial of f with respect to x has to be 1. So that means it has to have an x in there, right?
Okay.
But also, you could have a function in y and z that shows up. Okay, so the function is going to be something, it has to be this. It also, from this one, it has to be what?
Cosine
This is y.
or dy. So gonna be 0.
Integrate.
Integrate.
So you want something whose partial derivative with respect to y is just sine z.
So y sine c.
Yes, y sine z does the trick. And then you could also have a function in x and z. Okay, and then this last one, you want the partial of f with respect to z to be y cosine z.
Negative y sine c.
Integrate.
Oh, okay.
So positive y sine z. So the partial of this with respect to z is y cosine z. And then you could have potentially a function in x and y. Okay, now, so what function will do the trick?
Like for the
Yeah, for the what function is going to be equal to that and also equal to this and also equal to this?
is it the y sine c?
Yeah, there's y sine c plus what?
Plus x.
Plus what? Okay,
All
so
of
now
those.
here this is really important. You have to, I'm going to give you a chance to guess a number between 1 and 100, and you have to guess correctly. Okay? Otherwise,
50.
50?
Yeah.
Okay. Okay. Okay, great. Put that in, and you'll see it and see if you guess correctly.
Can it be any number at all?
Well, no, just 50. So, wow, I can't believe it. You guessed it correctly. No, I'm just kidding. Any number would work.
Oh.
Usually people don't put a number, but you can put anything. So, did you put this? Did this one work? Plus 50 work?
Yeah.
Okay. So, yeah, usually, you're not going to put a number there because that's just going to make your other calculations more difficult.